Okay, greetings everyone, and welcome into my channel. I am Professor L, and this live stream is for math help and doing math. Uh, a reminder that I will be hosting a live stream for math help and math information um, Monday through Friday from 6 p.m. to 7 p.m. Central Time. All right, so picking up where we left off Friday. So Friday, my live stream cut out about 36 minutes in, and I continued because I still had sound, and also this is new for me and I need to practice. So um, I did have a couple people watching, and they told me that they couldn't see my stream after 36, but I went ahead and presented anyway, and I sketched the graph of cotangent, and I left it up here because I thought it would be good. I am going to erase and sketch a new graph of cotangent. However, I realized that I sketched way too many points, and it took way too long. I sketched 1, 2, 3, 4 periods of this graph, and really, I think 2 would be just fine and necessary. So we are going to re-sketch cotangent and practice. It's very good practice for me to not be lazy and really get good at graphing on a whiteboard, almost a chalkboard. But also, it's the lost art of sketching a graph, and so that's what I'm doing with my live stream right now. Is I'm going through the graphs and getting a good solid understanding of what these graphs look like. It's really cool because, well, what I did was I sketched cotangent in the solid, and I sketched the asymptotes for cotangent in solid, and so you can see them. And then I dashed tangent and its asymptotes. So you can see visually very good representation of the differences in these functions. For example, tangent function is increasing. It's an increasing function. And what I mean by increasing is as your x values are getting larger, your y values are also getting larger. And so then that describes an increasing function over the interval of the domain. And you can see that tangent is increasing, whereas cotangent is a decreasing function. And you can see that visually. That's what caught my eye. Something else that caught my eye is these points in particular that I picked. Both functions share 2 of the points, not the third one. So it was cool because you could see the intersection, and even though the function is completely going the other direction, you can see the unique relationship between the function and its inverses. It's really cool. You can also see that symmetry, and get my ruler out real quick and show you that symmetry about the identity function line as well. And we'll see that again too at the end. I just wanted to leave that up for anyone that was interested. And I went ahead and completed it, and I didn't want it to be completely in vain. So I left it up just so it'd be a pretty good intro to what we're going to be doing today, sketching the graph of the cotangent function. And I'm hoping that if all goes as well, I'll have almost an identical graph, only it's going to be between negative pi and positive pi. And so it'll be just a smaller section of it. So we'll see what this looks like. And I also think it's important to go ahead and put up the graph of the tangent function as well. And look, it's not functions, it's just one function. Okay, so y equals cotangent x. And remember, that's y equals 1 over the tangent of x. And we'll start out with our little unit circle here. One comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. And we'll go ahead and sketch our Cartesian coordinate system about the origin. And I'm going to take it out to pi and negative pi. And we'll go ahead and get our table going. And we'll do cotangent there, and we'll do tangent here. Let's see how we do. Okay, we got all our x's. Let's see how good I can draw this circle this time. That's letting me know how good I'm doing. I'm getting more comfortable writing the math out and hanging out with the camera. All right. So we're going to start with the tangent of x, and recall tangent tangent of theta. So we put it in here. Tan theta. Oh, where are we going to start that? We'll put it here. Tan theta is sine theta over the cosine of theta. So we're going to go ahead and remember x comma y, and x is the cosine and y is the sine. So this was 0 plus or minus 2 pi. We only need the 0 degree because we're only going from 0 to pi and negative pi. So we'll need 0 degrees. We'll need pi over 2, and we'll need negative 3 pi over 2. Oh, we're not going to need that. Well, this is going to be harder than I thought. Okay, so we'll need plus or minus pi. We'll need pi over 2, possibly negative 3 pi over 2. We need 0. We need negative pi over 2. Honestly, let's go ahead and write our, this might be better. We'll go ahead and say negative pi over 2, positive pi over 2. Figure out our angles in our domain, what exactly we want to graph, and then we'll go find our angles. Okay, that might be better. We got x comma y here. So we're going to do pi over 4. So we'll put in negative pi over 4. And we're going to go to, that's 3 pi over 2. Hang on a minute. Pi over 4, pi over 2. We want to do 3 pi over 4 also, right? Let's see. This is 3 pi over 2, which is 270. We're only going to pi. So negative 3 pi over 2. So we need that one. Okay, so what is the deal here? This needs to be a little bit bigger because there's another point in here. Hang on, I'm gonna have to scoop all this over. Okay, so we've got pi over 4, pi over 2. There's another point in here, and then this is pi. And that is going to be the pi over 4 in the third quadrant, fourth quadrant. Okay, so make this one a little bit bigger. And then put negative pi there, one more point here, I think will be fine. And then that was 3 pi over 2. I'm not going here. We've got pi over 4. We need this one. That was that 3 pi over 4, and then this one was 5 pi over 4. Is that correct? Oh, one of these days I'm going to have them memorized. So 3 pi over 4, 5 pi over 4. Okay. See, and if I had people doing math with me, wait. This was 3 pi over 4. All right, never mind. I don't know what I was thinking. This is 3 pi over 4 and pi. 3 pi over 4 and maybe pi. Okay, I think I'm cooking with grease now. I didn't need to extend it. It's just been a while. All right. So hopefully I don't fail too miserably at this. Got it. So I didn't need this one down here because I'm only staying in these two quadrants, and then it's the negative of these two quadrants. So it's like a reverse. So it's the negatives. All right. And then I need a 1 here, negative 1 for my range. And then I'm going to redraw my table here for tangent. Okay, and breathe. Well, it's been a whole weekend since I've done any math. All right, so now I need to go ahead and just list the values in my domain that I'm going to evaluate, starting with the least to greatest. So I'll just see if I can fit them in here. Negative pi, negative 3 pi over 4, negative pi over 2, negative pi over 4, 0. And then we'll go pi over 4, pi over 2, 3 pi over 4, and pi. I'm going to fit them all there, barely. All right. And then we're just going to recall those values. We're going to evaluate the tangent function here at pi. So tan of pi is 0 over negative 1, which is 0. So we can put 0 in at pi, and we can also put it at positive pi. And then we're going to go to our next value, negative 3 pi over 4. And this is positive 3, so negative 3 pi over 4. That's positive pi over 4 is going to be here, right? And I erased it, but let's go ahead and double check. Is that my negative 3 pi over 4? to think about it for a second. So I've got negative pi over 4, negative pi over 2, negative 3 pi over 4 is down here. Okay. Because I will flip things around, I always have to go back and originate. How did I figure out those angles? Where are those angles existing? And this one's over here in the third quadrant going in the clockwise motion. So tangent of, recall, 3 pi over 4, this was, well, it's negative radical 2 over 2, comma, negative radical 2 over 2. So tangent of negative 3 pi over 4 is going to be negative radical 2 over 2 divided by negative radical 2 over 2. And anything divided by itself is equal to 1, and 2 negatives divided out also makes a positive. So at negative 3 pi over 4, we have tangent at 1. And then negative pi over 2 is here. And we have tangent is negative 1 divided by 0. So tangent of negative pi over 2 is negative 1 divided by 0, undefined. It's going to leave to your asymptote at negative pi over 2. And then negative pi over 4 is here. And you've got, so you're going to have cosine, so negative sine. All right, tangent, I'll just write it out rather than getting in too big of a hurry. Tangent of negative pi over 4 is going to be positive, or negative, sorry. So it's sine over cosine. So negative radical 2 over 2 divided by radical 2 over 2. So that's going to give me a negative 1 at pi over 4. And then 0, we have 0 over 1, which is 0. And then pi over 4 is positive. So that's going to be positive 1. And then positive pi over 2, we have 1 divided by 0, undefined. And then 3 pi over 4 is going to be 0 divided by, hang on. So that's going to be negative 1 because it's cosine is negative. Negative radical 2 over 2, comma, positive radical 2 over 2. So that's going to be negative 1. And if I've accurately sketched this graph, is that correct? Oh, I did that really quick. All right. So I'm going to go ahead and sketch the graph at negative pi, I'm at 0. And I'm going to dash this one. At negative 3 pi over 4, I'm at 1. And negative pi over 2, I'm undefined. And then negative pi over 4, I'm at negative 1. And then 0, I'm at 0. Pi over 4, I'm at 1. And then pi over 2, I'm undefined. And then 3 pi over 4, I'm at negative 1. And then pi back to 0. Okay, so well, let's quickly dash this graph in. And that's that one. And then it looks like we've got that one. And that is what's going on with this one. All right, so there's tangent. And then let's go ahead and do cotangent now. So cotangent is the reciprocal function to tangent. So you're finding all of its values by just putting tangent and then 1 over tangent. Just putting literally tangent in the denominator and figuring out those values. So by definition, cotangent is, let's put it in here somewhere. Cotangent theta is, so if tangent, where is it? Tangent theta is sine over cosine. Cotangent is 1 over sine over cosine. Then cotangent, when you invert and multiply that second denominator, you're going to end up with cosine theta. Maybe I'll just show it real quick. What this means is 1 divided by sine over cosine. So you have 1 over 1, and you invert and multiply that second term, and you get cosine theta over sine theta. So that ends up being cosine theta over sine theta. So you can say cotangent is cosine theta over sine theta. And simplify your work that way. So you're still going to pick the same values in your domain that you want to evaluate. We'll evaluate these same values so we can see the differences in these two functions, and also the similarities. It's how they relate to each other. They're inverses. One inverts the other. So we've got pi, -3 pi over 4, -pi over 2, -pi over 4. We've got 0, pi over 4, pi over 2, 3 pi over 4, and pi. And looky there, we got some room on the bottom. Okay, good. So when we're thinking about our unit circle here at -pi over here, and we've got the cosine is -1 and the sine is 0. So I'll make this a little bit shorter, cut it off a little bit shorter down here so I can make my calculations. I think I can get away with it. With all the arrows. Okay. And we want to be correct, so we're going to go ahead and get our arrows in there. So we've got the cotangent of -pi is going to be is cosine of -pi over sine of -pi. So that equals -1 over 0. So that first value of pi, undefined. Okay, that's also positive pi because of the cyclical function. Okay. All right, we've got those two values clear. So now we're going to go to -3 pi over 4. Cotangent of -3 pi over 4. We're going to come over here and find -3 pi over 4 on our unit circle. And remember those values, negative radical 2 over 2 over negative radical 2 over 2. So that is just 1. When you divide those, you just get positive 1. We already did that a while ago with tangent. All right, so we've got that. And then we've got negative pi over 2 here. So that's this value right here. So we're looking at the cosine over the sine, cotangent of negative pi over 2. And so we're going to say cosine over sine, and that's just 0. So we've got a 0 value there. Negative pi over 4. Hopefully I'm not going too fast. Cotangent of negative pi over 4. And recall negative pi over 4 is here. And that was cosine was positive, so we got radical 2 over 2. And then the sine was negative, so radical 2 over 2. So we're doing cosine over sine, so that's going to be positive radical 2 over 2 over negative radical 2 over 2. So it's going to give us negative 1. Cotangent of 0 degrees here. Oops, I'm in the way. 0. We've got cosine over sine. Cotangent of 0 is going to be cosine over sine. To get out of the way. That's going to be undefined. And then we've got pi over 4 right here, the first quadrant. This is radical 2 over 2, comma radical 2 over 2. So that's just 1. Anything divided by itself is equal to 1. And then pi over 2 here is cosine over sine. Cotangent of pi over 2. Cosine was 0, sine was 1. So that's just 0. And we've got one more value and then we're done. Cotangent of 3 pi over 4. And here we are in the second quadrant here. Recall, we got negative radical 2 over 2 divided by positive radical 2 over 2. So that is going to be negative 1. And if I worked all of that accurately, I should have plotted my points. Got my ordered pairs so I can plot my points. And I'll leave this up just temporarily, but eventually erase it because I want to put the domain and the range in there. Okay. All right, so we've got our ordered pairs. Let's go ahead and put our points in here. Let's start with our asymptotes. So we've got an asymptote at negative pi. So I want to make these bold now, so I can have the difference between these functions. So even though this is an asymptote and I would typically dot it, I already dotted the tangent asymptotes. So I want to make sure that these kind of stand out. So we've got one also at pi here. Hopefully I can do good drawing these pretty straight. Right, and we've got one at 0. We're just going to leave it there because it's already the y-axis. Right, so now we're going to put these other points in here. At negative 3 pi over 4, we're at positive 1. It's already there on the graph. And then negative pi over 2. Right here at this asymptote, there's actually a value for cotangent. So we'll put that on there. And then, let's see, we're going to go to pi over 4. We're at positive 1. It's already up there. Make it bigger. Pi over 2, we have a 0. And then 3 pi over 4, it looks like we're at negative 1. Negative 1 down here. And this one's also on there. Also. Okay, so let's go ahead and just put this curve in there. And remember, it's bending towards its asymptotes. Okay, good. Interesting. So, I'm going to put that up yet. All right, so I'm going to go ahead and erase all of this dirty work and go ahead and write the domain and range of cotangent. And I've really been thinking about what I want to do next. And there are a lot of transformations in the graphs of these trig functions. So I don't know if I want to sketch a couple examples of that, or if I want to, I don't know. I'm trying to decide what I want to do next. This completes all of the basic graphs of all of the trig functions. Shy of, there are a couple of inverse functions for these reciprocal functions, but we'll probably cross that bridge at a later date. I'm probably going to move on. Haven't really quite decided what I want to do next. So I have also thought about maybe trying to get into showing the circular coordinate system and maybe possibly trying to solve some trigonometric equations. I don't know. We'll figure it out. So I want to go ahead and state the domain and range of the cotangent. I'll flop my parentheses up there. And then we'll call it good because I've already been, it's good, solid 30 minutes. So we're talking about the domain. We're looking for the places along the x-axis where there would be any restrictions. So we're going to go ahead and we'll say that this graph for cotangent is going to exist everywhere except for where you have these vertical asymptotes. And notice they're appearing every pi value. So it looks like intervals of pi. So we're going to say that x, because the domain is the set of all x values, all independent values. X is a real number, but x is not in pi, where n is an element of the integers. And that should cover all the values in the domain. And again, when you're stating the domain of one of these rational functions, and you're having to deal with, sometimes if it's only one asymptote or two, it's a lot easier to use interval notation. But when you're dealing with a periodic function with asymptotes, I haven't really found a way. If anybody does and wants to put it in the chat, that would be awesome. But find a way to state these kind of functions, domains, in interval notation. But for now, we're just going to use the set notation. see if I can spell it right today on Monday. Set notation. And then for the range, there's no excluded values in the range. The set of all y values of the dependent variable, the range. So it's a lot easier to state that because that's just going to be negative infinity to positive infinity in interpolation. notation. All right, so not too bad. The cotangent function, okay? And you can really see, we'll go ahead and put up this ruler one more time. You can really see that symmetry along the identity function line here, going through of the function. And again, we have graphing features, we have computers now, and we can really get a good idea, and we can get a really good picture now of the graph. But can we do it by hand? It's important to be able to stand alone without your tools. Sometimes it's good to be able to articulate methods without the use of the technology. Okay, very good. So that is going to conclude my live stream for today. I don't have any questions, so I'm going to go ahead and wrap it up. But I will be back here tomorrow, just in case anybody needs help with their math, and I will figure out something to present to be useful in the meantime. So I hope everyone is having a wonderful Monday evening, and thank you so much for watching my videos. I'll see you next time.